Hi, and welcome to C Sharp Programming on .NET. My name is Brett Robley. I teach at Cal State University Fullerton, and this class is ISDS 309. I'm going to create a little video lecture tonight on using data in C Sharp. In Chapter 2 of Joyce Farrell's Microsoft Visual C Sharp 2017, she deals with C Sharp data, primitive types, and I've got a little program I put together here to illustrate and demonstrate some of the data types and operations. So let's open up Visual Studio and let's create a new project, make sure it's Visual C Sharp and a console app, and we'll name it using data. We will remove all the lines except for line 1 using system to bring in the system libraries, and in line 2 I'm going to say using static system.console, which gives me a shorthand way to call methods against the console object. So we'll be able to call write and write line to display to the screen and read line to wait for input from the keyboard without having to type console.write or console.writeLine. So that's what using static system.console buys us. Now, every application is contained in a class, and there's two kinds of classes. There's an application class, that is one that contains a main method, and then all the other classes, non-application classes, that do not contain a main method. Now, the compounding interest formula is, as you see on your screen, A equals principal times 1 plus the rate divided by the number of compounding periods per year, with that quantity raised to the power of n times t, or the number of compounding periods per year times t, which is the number of years you hold the investment. So of course, we understand that the exponent, or the power, nt, is applied to 1 plus r over n, and then finally multiplied against the principal, yielding our compound interest, or the total of our investment, which is stored in A. So here at line 12 is an example where we create an identifier called prog name, short for program name, and we declare it to the left there that it's of type string. The equal sign is really an assignment where what's on the right hand of the equal sign, the literal string compounding interest, is stored in the identifier program name, or actually the memory that is identified by the identifier program name. Then we will write out the program name, and that's a string type. Now I'm going to create some doubles, A for the accumulated investment, a double P for the principal. Doubles allow you to hold rational numbers, those with fractional portions. Float is like a double, only it's just less precision. And so R stands for our interest rate, which is expressed as 6/100ths, or 6%. And then T is an integer, meaning it's a counting number, no fractional portion, and we'll set that equal to 1. That's the term of our investment, 1 year we're going to hold this investment. And then the integer n equals 1. N is the number of compounding periods per year, and so 1 would mean annual compounding. Now, C Sharp, unlike other curly brace languages, does not have an exponentiation operator. And so I have to rely on a library function, or a .NET framework class and method called math.pow. On line 20, math.pow takes the first parameter in the parentheses, the 1 plus r over n, and raises it to the power of the second parameter, which is n times t. And then it multiplies all of that times p and stores the value in A. In the write line statement, I'm going to write out the two strings. Well, yeah, two strings. The first one is yearly, and the second one is the value A converted to a string and formatted into currency. That's what the quote C does for you. Now, what I'm going to do is I'm going to copy these lines and I will replicate these lines 3 more times. And the reason I'm doing this is so that I can show you the difference in our investment return as I increase the number of compounding periods per year. So when I say n is equal to 1, that's annual compounding. When I say n is equal to 4, that's quarterly compounding. When I say n equal to 12, that's monthly. And of course, when I say 365 in the next one, that is daily compounding. Now, if you calculate interest more frequently, such as every day, then you should get more of a return on your money than if you didn't compound it every day. And I think that the program will show us that once we run it. Okay, I'm going to insert a read line here so that the program will not continue without us being able to actually observe the output. So read line will cause the program to pause, waiting for input from the keyboard. Okay, let's give this a try. See if I have any errors that we need to fix. Okay, no, it looks good. Now notice yearly is the lowest amount, daily is the highest amount. It's not a lot, but it is accurate. And then I went to Excel and I wanted to check my work, and you can see that the values here are the same as what the program generated, plus or minus a penny. And then the formulas behind it look like this. And that concludes this video lecture.